Paired sample t-test. Example. Athletes performing in bright sunlight often smear black eye grease under their eyes to reduce glare. Does eye grease work? In one study, 16 student subjects took a test of sensitivity to contrast after 3 hours facing into bright sun, both with and without eye grease. Here are the differences in sensitivity with eye grease minus without eye grease. We want to know whether eye grease increases sensitivity to contrast on the average. Do the data support this idea? Use 0.05 significance level. We have a data set. It is differences with eye grease minus without eye grease. With eye grease minus without eye grease, then we can write down mu d, mu1 minus mu2. Mu1 is the population average of with eye grease. Mu2 is the population average without eye grease. Therefore, mu d equal mu1 minus mu2. Eye grease increases sensitivity. Always eye grease numbers should be greater than without eye grease. Therefore, what will happen to the with eye grease minus without eye grease? Since with eye grease numbers greater than without eye grease, with eye grease minus without eye grease should be greater than 0. That means mu1 minus mu2 greater than 0. Mu1 minus mu2 equal mu d. Therefore, average of the differences greater than 0. So, this is the key. If average of the differences greater than 0, mu1 greater than mu2, then what is the null and alternative hypothesis? Mu d equals 0 and mu d greater than 0. Why? Go back to the claim if you don't understand. We want to know whether eye grease increases sensitivity. Eye grease increases sensitivity means mu1 should be greater than mu2 or mu1 minus mu2 greater than 0. Mu1 minus mu2 greater than 0 means mu d should be greater than 0. Then go to a test statistic. We know this is match pair sample. We have differences. So we use match pair t-test. It is xd bar minus sd over root 10. So we have all the information. So how do we find xd bar? We have a data set. So use the data set to find the xd bar. How do we find sd? Use the same data set to find the sd. And then square root of n equal 1.79. Therefore, test statistic is 1.79. Then p-value. We know how to find the p-value. This is a right tail test. So, the p-value equal probability t greater than 1.79. Find the two numbers in the row with degrees of freedom 15, which enclose 1.79. They are 1.753 and 2.131 with one tail p-value of 0.05 and 0.025 respectively. Now go to the decision. What is the decision? 0.025 less than p-value and p-value less than 0.05. It means p-value is not equal to 0.05, it is less than 0.05. Again, you see that p-value less than 0.05, but alpha equal 0.05. Therefore, p-value less than alpha. If p-value less than alpha, we reject S0. Therefore, S0 is not true. We go with HA. What the HA mean? Alternative hypothesis say mu d greater than 0. Mu d greater than 0 mean mu1 minus mu2 greater than 0. That means mu1 greater than mu2. Yes. Conclusion. At significance level of 5% of the data provide sufficient evidence that the eye grease does increase sensitivity to contrast. Why? Mu1 greater than mu2. We accept actually HA. Think about this way. You have the same problem, but we have here without eye grease minus with eye grease in the opposite way. Then You see, without igrees minus with igrees, it is mu2 minus mu1. Then what will happen to this without igrees minus with igrees? You know, if igrees increases sensitivity, again always with igrees should be greater than without igrees. That means with igrees minus without igrees should be less than 0. This implies to the mu1 minus mu2 less than 0. That means mu d, average of the differences should be less than 0. Therefore, our hypothesis should be changed. What is that? Mu d equals 0 and in this case mu d less than 0. Thank you.